how exciting. Fantastic. Hey, so, oh, this is odd up here, but we can get used to this. Well, welcome to the session, Mapping Open Source Science. We are going to be exploring a project that's being developed out of an initiative in NumFocus, which is a fiscal sponsor for a lot of the data science stack, NumPy, SciPy, projects like that. And let's just get into it. So very quick, this is me. There's going to be a QR code in the bottom right. You can scan it at any point. That'll take you to a link tree. A lot of resources there for more information on the project, more information on the program at NumFocus, which I'm the program manager of. OK, so I was hoping to start a fight right in the beginning by asking people which they are a fan of first. But I'm just going to jump into the fact that I am a fan of Star Trek for a very for a very specific reason. That Star Trek is focusing on building for the future. Star Wars is a long time ago in a galaxy far, far away. Star Trek is a couple hundred years from now. We could imagine living in a world that exists exactly like what was on that show. The issue is we face a lot of challenges as a society that are standing in the way from us to get to that reality. Climate change is a very good example of that. But there are many others throughout society, and open source is a potential solution or a contributor to a solution to many of these challenges. And if we want to actually build a future that is inclusive of everyone, that sees the best of humanity, the drive to explore, the drive to help each other, and develop technology that is used by local communities and not just by large tech companies, we're going to have to get a roadmap for getting people involved in this system. So the perspective I'm coming from with the project that I'll be talking about is from the scientific perspective, because again, NumFocus is data science focused. But I think this type of project can be adapted to most, if not all, of the open source system. So this whiteboard can be a very early introduction to what we're about to explore. This is from PyData Vermont in late July of this year, where we had a bunch of people from the community. For those who don't know what PyData is, it's a localized Python hacking community, essentially. You come together and talk about your project and do some interesting stuff at the event. So we had everyone there in Vermont start mapping out what the research system looks like in Vermont. We have the University of Vermont. We have a bunch of companies there. We have a bunch of people that contribute to a bunch of projects, some which are very local, some which are global. And this we ended up putting into what we're building, which is the map of open source science. So that small whiteboard of just a couple nodes, we are going to explore into a couple hundred thousands of nodes. So this is the University of Vermont. And when we're building this system, when it comes to academic institutions, what we need to think about are why universities need to have a map. Why they need, what they would use this for. So essentially, there's going to be 4 stakeholders. One is the academic institution. And what academic institutions need to do is be able to track who's producing what software and how that software is being used in research. What papers are coming out of that software, and how is it getting funded, and many other factors. Is there collaboration with other universities? Are there people connected to other organizations that are also contributing? So when we mapped the University of Vermont, we can see the green nodes here are people. We can see the orange nodes are domains, and we can see, well, it's kind of hard to see the projects themselves, but there are projects in there surrounded by the people that are mapped to each of those domains. So if we expand this out, as we'll do in just a minute, we'll be able to see which open source projects are critical to which domain. So something like health sciences, climate sciences, which software is going to help us get to a better future for society, help us achieve something like the Sustainable Development Goals of the UN. So there's another stakeholder in this system beyond academic institutions, and that is the projects themselves. And this is a picture of So you're going to see a lot of the green are people, and that little sun-like thing is scikit-learn. It's a single project, and all the yellow nodes are the papers that cite scikit-learn. So what we were asked to do is determine the impact of scikit-learn in the ecosystem, and this is going to come up again later. What does impact mean? The definition of this ask of impact was how many papers are citing this project. So we were able to trace this loosely and show this impact of scikit-learn and continue to place it within the ecosystem. So now what we did is add the number, the authors of all those papers, attach them to the papers, and then attach those papers to scikit-learn, the project. And again, this is just going to be one node. All these other nodes off to the side are a lot of other contributors to the ecosystem. But once we had all the people mapped, we could map them to the organizations. And you can see scikit-learn being a giant, I kind of think it looks like an eyeball. Some people think it looks like a neural system. But it's a giant node of interconnectedness within the research ecosystem connected to the machine learning space, the machine learning domain, which you cannot really see in this image, but you can see a couple of the red nodes are projects, so you can see a couple other projects that we haven't mapped. And you can imagine this system, as we map out other projects, starting to highlight which of these authors are using are writing papers that are using different pieces of software. Which of those pieces of software are being built by the same people or different people? Which organizations are supporting those people and those papers and are all interconnected? And you can start to see these bridging. So we started to do that, and you can see in the bottom left here, you can get a feel of the early forms of the rest of the ecosystem. This was largely the data science ecosystem, non-focused projects, et cetera, but you have scikit-learn, that big eyeball, now a little compressed off to the side, and you have a bunch of other projects. And there are, you can see one towards the bottom sort of middle, one connection from the scikit-learn ecosystem into the rest of the num-focus ecosystem. And that is a very interesting bridge that someone who's looking for a way to both support something like scikit-learn and projects that are used alongside scikit-learn, as well as the people that are contributing to both. Someone might want to follow that thread through to the rest of the ecosystem and see what's going on in there. So we continued this mapping, and now you're going to see the blue collections, which are dependency graphs. You're going to, of course, see scikit-learn, which is now shifted to the bottom, and you're going to see a larger, more robust map towards the top. The yellow lines are complementary projects. We also have mapped alternatives, and it's just a growing ecosystem, largely, again, based around one project. So what we're doing is mapping many more projects, and we're getting to the point where we're getting a very, very, very large knowledge graph. Okay, so that's an introduction to the project. Why does this matter, and how does this relate back to Star Trek? And I'm going to go a little off here because I just came from the diversity lunch, which was a wonderful conversation. We were talking about how to bring more people into the space of varying backgrounds, various experiences and traditions of learning and doing. And I came across this stat recently, and I thought it was very serendipitous. So there is, this is a UN study, I believe, from 2020. 38% of the world has access to what we would call higher education. That's a crazy low number. Yet in open source, the primary on-ramp to software development and open source is higher education, is a mentorship program. Things that largely don't exist in a lot of the world. If we want to grow a robust open source community, we're going to need to build a way for other people who don't have access to the things we take for granted every day. We're going to need to build tools that let them come into this ecosystem. Someone with a curious mind who might want to explore astronomy or some aspect of science and use software to do that needs to figure out what data sets they can use, what software they can run over those data sets, and where they can find community to teach them the traditions of open source, the philosophy of open source, how to use Git, things like that, that exist outside of the academic institution. This 38% raised from, I think it was 17 or 19%, 20 years before that. So we've gone, what, 20% in 20 years? It's going to take a long time to get higher education across the world. So we have to have a different way. So what we're building is a map to get more people into this system. It would be crazy to think of going on any sort of adventure without a map. We have Google Maps today. Google Maps is a way we can explore the world using a singular data set with a bunch of different toggles on top of it, and it gets us from point A to point B. Why don't we have that for the digital knowledge ecosystem? So this is what something, a user like this might experience when they go through a map that's bringing them onto into open source. So this is, the reds are projects, the whites are domains. This is still a little overwhelming. This is just the NumFocus ecosystem again. Just because we put everything in a knowledge database, knowledge graph, doesn't mean we're going to solve the problem, right? There's still going to be noise. But what we can do is filter it. So this person's interested in astronomy. So they look for the domain astronomy. And they see immediately there are 7 projects here that are used in astronomy. And these are indicated of use through social layers built on top of this database. But you can see the nodes increase in size based on value defined by this person as they enter the graph, as they start using it. So this is a good way they can start getting into astronomy. They have to find out what AstroPi is and SunPi is. And then maybe they want to find out what tools are used complementary to these other tools. So if they're going to learn how to use SunPi, what else should they learn to use? They need SciPy. If they learn SciPy, well, SciPy is not connected to another domain. So they'll use Matplotlib, very common, popular visualization tool. And because they've learned Matplotlib, they can now see that they have access to a bunch of other domains that they can start to explore. They can start getting more into data science and some other stuff. So by simply saying, I'm interested in a field of research, I want to use software to explore that field, they've been given a pretty straightforward path into open source. And from here, there are a lot of other tools we can map. I'm hopefully going to be able to show you how this works. But from here, you can explore different communities, different organizations within open source, things like fiscal sponsors, things like foundations, and other types of organizations. So as we build this tool, we start to get some pretty cool visualizations. So the next couple slides are just these visualizations. There are a couple other stakeholders, though, that I want to talk about as I go through these slides. We've hit academic institutions a little bit. They need to see who is from their institutions contributing to open source and in what field of research they're contributing, the papers that are coming out, things like that. We've hit the projects themselves. They need to be able to explain their impact and why they're important, the dependency graphs, the citation graphs, very similar to academic institutions. What about funders? What about people who rely on essentially users, people who rely on this software to get work done in a very specific domain? Well, it's complex, but essentially they need to be able to predict what their funding is going to do if they want to support a project, and then measure whether or not their funding actually achieved that and how that project's being used. So they have another definition of impact that they need to apply over a database of the open source and open science ecosystem. So how do we measure impact? Impact is not a singular thing. It's a definition that changes every day. What's important to me today, if I have an impactful day today, is going to be a completely different definition tomorrow. If I'm looking at open source projects, my definition of impact today is going to be completely different than it will be tomorrow. Today it might be a dependency graph, tomorrow it might be a citation graph, et cetera. So what we need to give to funders is the ability to define what they're calling impact on a given day, a given week, and then apply that definition across the knowledge graph, across the data set, and then see a visualization of that they can understand. Because like it or not, funders do not exist in the open source world. They exist sort of above it. They can't understand the intricacies of the world in which we live. So we need to give them tools that let them make decisions without burdening them with too much knowledge. This is a very fun one. I think this is just people. Every green node is a person. So this is a interpersonal graph of open source. Again, very limited data set, but it's starting to grow a little bit. And this kind of speaks to the fourth user, the fourth use case that we want to primarily build for. We've got the academic institution, we've got the project itself, we have the funder, and what about us as an ecosystem? This again came up at the diversity lunch today. Open source is much larger than the community immediately around us. It's much larger than the people that can make it to these events. Open source is all around us, despite the fact that only 38% of the world has access to higher education. And we need to be able to see what everyone is doing everywhere in the world. We need to be able to recognize people who are not capable of making it to these types of events, because these types of events, as beautiful as they are very exclusive. They're exclusive by nature, it's just what they are. A good way to do that is to simply map relationships and let people define their own relationships in the map. So start by scraping GitHub, perhaps, and see who's contributing to what project. But then give that power to write to the database, to the community itself, so that I can go in, I can claim my node, and I can say I am related to person A, B, C, and D, and they are related to XYZ projects. And then let other people come in and attest to that claim and build a social graph on a knowledge graph, getting to a lot of graphs, and let that grow over time as an organic object owned by no one and permissionlessly accessible. This is just very pretty. I have nothing to say about this one. So we'll move on from here. And this is kind of where we're at right now. Although we're starting to get to maybe 3 or 4 times the size of this, we're starting to map with some universities themselves. We're building out the helping the UC network in California build out some information about how their institutions are using open source. We're working with some other OSPOs to build out their systems. We're working with a couple organizations to build out their systems and how they're contributing to open source. And people are seeming to like the ability to show off their contributions to some of these projects. And one of the impacts, one of the things we hear when we're talking to people about how they would use this or what they want to see with this is the ripple effect of removing a project from the graph. So if you're trying to explain to someone at your company or someone who's supporting your project at an institution or a funder, for example, if you're trying to explain why your project is important and why it needs to continue to exist, you need to show them what's going to happen if your project stops existing. That's a very difficult thing to do, particularly when we live in, this is coming from a talk that happened yesterday about $1 billion for open source. When we live in an environment where maintainers and contributors to open source are incredibly passionate about these projects, and we're not going to stop working on them, even if that will probably show how important a lot of these projects are. But we can hypothetically stop working on these with a graph of relationships of these projects and what their outcomes are. So if we can visualize what happens when you take something like NumPy out of the world of open source, the ripple effects that causes, and all the organizations and their outputs, how those are affected, it might be easier to find support for that type of project. An additive way to do this, instead of showing what a possible negative outcome could be, an additive way would be mapping patents. So ultimately, what we're trying to do is map everything in research and open source. One of the things that exists in there is patents. So if we can go for an open source project that's used by a researcher to produce a paper, which is used to produce a patent, which is used to produce a product, which is used to produce economic velocity, and then we can measure that economic velocity, we might be able to give a number to how valuable a piece of software is, as well as a piece of research, everything along that pipeline. And there is interesting technology being developed that we might be able to actually algorithmically drip funding from the product all the way down the pipeline to everything that was used to produce something like toothpaste. So when you're making money with your product, that depends on open source software. You are also funding the infrastructure that allowed you to make that product. So instead of a project having to convince someone to give them funding, they're just given funding because their project is useful. There's another sort of field that we're starting to explore, which I'll get to after a quick summary of these questions. So these are the four archetypes I went through. So how can we show what tools are being used in what domain and for what specific purpose? How can we give academic institutions the ability to showcase what tools are produced within their institution and who is building and maintaining those tools? How can we give funders the ability to identify where they put money to best advance their goals, how to predict their impact, and how to trace that impact, build a predictive algorithm to help them fund more open source software that they'll use in the future? And then, of course, how can we give the community the ability to elevate itself and become self-aware, become aware of my neighbors, what they're doing? This is crazy in academia, actually. There's we talked to a lot of researchers while building this. There's a lot of people who meet someone who is working on an identical research topic or identical piece of software, and it works down like the hall from them at an academic institution, and they meet for the first time at like a conference in an entirely different country. That's wild. If we're able to map the people that exist at an organization, at an academic institution, and the software that they're building and the papers that are coming out of that, you're going to find you have colleagues right next to you that you should probably be collaborating with and building some really cool research, publishing early, things like that. So that I will show you this other use case that we've just started to explore, and I alluded to it earlier. There's also the 38% is related to one of these. It has to do with the SDGs, Sustainability Development Goals of the UN. We can map what software is critical to the advancement of these SDGs. The higher education, I think, is SDG 4. So if we can show to the world who's starting to come on board to these SDGs, to advance them, to elevate the development of countries towards these goals, which are things like life on land, life on water, gender equity, education, that's pretty impactful. That helps us convince governments to fund open source software at a level similar to the sovereign fund that's set up here in Germany. This would be a wonderful thing to be able to showcase, and again, at a level that people intuitively understand. So we don't need to explain an SBOM or a dependency graph. We can just show them, hey, you're interested in higher education? Here's software that we can prove to you, if you really want to get into the details, that's being used in advancing higher education. And this speaks to a talk earlier from Tyler about mentorship. Here are programs that are onboarding people into open source through software that is advancing the SDGs. So on this visual, you've got 3 SDGs, and I'm only showing 3 here because there's 17 of them, and it would crash my computer if we map all the software that's critical. Like this also exemplifies how important software is to our world, to our society, to creating Star Trek. But there's 3 of them here, and you can see in the middle, there's no SDG here. What exists here, why there's a cluster there, there's obviously critical software that is, there's obviously software that's critical to all 3 of these SDGs. This would be the software that we want to show to governments and say, this is pretty important to continue funding if you are interested in these 3 of the SDGs. And I imagine this cluster can be applied across all 17. There's probably some very common software packages and libraries that go across all 17. So this is what we're building. I was hoping to be able to have more of an engagement thing, but we're all in headphones. is a little bit awkward. So if anyone has any questions, I can talk about, I suppose, how we're getting the data, how to get involved, that sort of thing. But I would love to have a conversation. I can also, you know what? Let me end on this note. So I'll go through. I've got 4 different maps here. And I think internet is good enough. My computer's behaving. I think I can show you them. Perhaps not. This is what the interface looks like, essentially. This is the full version. So we have the different nodes. You can toggle onto it. The whole point of this is for it to be a modular, interoperable interface. So we're building that underlying layer, the knowledge graph, and then we want that, as I said, to be permissionless. Anyone can read from it. Anyone can write to it without any central authority saying what the truth database is. And then over that, there are layers. There's interface layers and there's social layers. So social layers help verify and validate attestations and claims made across this database, saying that a project's used in one domain, or I'm related to this other person, we work together on this one project. And the interfaces are meant to be, we want to let any organization build their own interface over this knowledge graph. So if you work at an academic institution and you really just want to showcase your tools and your contributions to open source, don't build your own database. Use a giant shared database of everything and build your own interface. So you can continue to add to that giant database and let other people build interface that shows the relationship between two institutions. Because one thing we have learned while building this is other people are building this, but only different parts of it at once because they find it useful, that granular part. And they don't know that there's like probably a dozen or two initiatives building some aspect of this graph. That we don't know that each other are building this. So if we were able to recognize that we're all building the same thing, which is just a giant database, let's merge that database and then build the different interfaces on top. So what that might look like is the ability to turn on different nodes when you want. So we can turn on people, we can turn on projects, we can turn on data sets, and then define the relationships that we want, map them as we see fit. So these are the relationships we're exploring right now. This is still very much an experiment, but connect people to people, people to projects, projects to domain, papers to authors, that sort of thing. And if this is loaded, it has loaded. So I'll show you what that looks like. The reds, it might be a little blurry. The reds are people, the greens are projects, and I can now people to, I guess I haven't hit that, put that relationship in this interface, but I just connected all the people, or all the projects to the academic institutions. So you have the University of Vermont here, and all the projects related to it connected to it. So you can imagine adding, a couple thousand institutions, layering them on, and starting to see where these institutions actually collaborate instead of existing in their silos. So the story I was hoping maybe to tell here, as we go through. Ooh, wonderful! I loaded this maybe 3 hours ago. And it looks like it just loaded, so great timing. This is a early map of an organization called SciLife Lab, and they produce a lot of papers, and they have a lot of authors that produce those papers. So this is what their graph looks like. Obviously incredibly noisy, but what can be done is the development of an interface that filters some of this and lets the user guide their own interactions with this graph. This is the user pathway for getting people into open source who don't have access to traditional hubs of knowledge. And then, I'll end with this story. So it's not really a story, it's just like a great thing that happened. I got married in August, and we had our wedding in the Dolomites. What we did is we hiked Alta Via 1 over the course of, oh gosh, I hope I get this right. I think it was 6 days, but it would have been crazy for us to do that without a map. Absolutely insane. It's well-marked trails still, don't get me wrong, and it's a beautiful hike, highly recommend it. But gosh, if we were just jumped into this foreign country, we didn't speak the language, thankfully, English speaker, so I have a little privilege there, but, and told, now hike from north to south, see you at the end, we would have died, but we do have maps. They guided us from the beginning to the end based on how we wanted to interact with that interface. And that interface was a beautiful trail and a lot of cows. So why is it so nuts to think that, hey, we should have that for the digital knowledge ecosystem? We should give people the ability to choose their starting point, say where they want to go, and then give them a map of how to get from point A to point B. And if something happens along that way, if a trail's closed or if there's a security flaw that creeps up, give them the ability to change the path for them. So one of the things we map for that example is alternative projects. If you have if you rely on a project and then a security flaw is identified in that project, what can you switch to immediately, and maybe with 5% time spent adding the features and the functions to continue your work while you assess the security risk that was just raised along your trail. Gosh, all right, well now I've got to ramble a little bit because this also brings up the idea of there's too much open source. There are too many projects. We are innovative people. We see a project, we want to change it a little bit, so we fork it and we make our own project. And coming from NumFocus, we deal with the research ecosystem. It is 1,000 times worse there because the researchers who are given money to develop software for their specific research don't have a map. They don't know what software already exists that they could just use. So they develop something, and they also don't know how to code. So they develop professorware. They develop really bad software that's used once, but it works. And it works for a niche field or something, and it would be incredibly useful for other people. But no one knows it exists because they use it in their research, and then it goes away. It's not put on a map. So what this graphing can do, what researchers could do market discovery, for lack of a better word, product discovery, tool discovery. They could find out what research tools exist in geology, in astronomy, and what are the features and the functions of those tools. And then instead of building their own professorware, go to that community and say, hey, your tool does mostly what I want, but I really needed to do this one very specific thing. Can you help me build it? Sure, we'll help you build it. We love building things. So that reduces the bloat in the system, which reduces the noise, which selfishly makes it easier to map because we don't need to scrape 10,000 projects. Hopefully we need to only scrape 1,000 projects. And it also has the potential effect of changing the way that we see open source fundamentally. Instead of a bunch of independent projects working on our own thing, feeling it out and then abandoning it when we get a life or a different job, we can be seen as a collaborative, a group of people centered around cores that are maybe field specific, domain specific, or infrastructure specific. AstroPi is actually a great example of this. They are a singular project within astronomy comprised of dozens and dozens of libraries. If we're able to build a core and satellite system because we recognize what one another is doing and we recognize that, hey, we could just work together instead of build our own things, we achieve something that we're trying to achieve with this map in a much more difficult way, which is simplify our ecosystem, make it easier to explain to funders what to support and why. You don't need to explain, the 300 packages used in astronomy. Just fund the astronomy core, and that core has a contract on how it governs itself, what the community is comprised of, and how it distributes funds, and how it distributes benefits to maintainers and developers. All of this just by getting a database of everything that exists in open source. And there's so much more, so much more. But anyway, so I got married in August. And it is a lovely experience. And it really reminds me, I guess, and I hope everyone else, if you're in relationships or if you're part of a community, that we're not alone in this world. We're not alone in our dreams and our hopes to reach Star Trek. And something else that might help us remember that is seeing the people that contribute to this ecosystem. And we're going to freeze again, which is unfortunate. It would have been really impactful if the green, so a green sphere will appear at some point and go, hey! So these are the thousands of people that contribute to a handful of NumFocus projects. And I will definitely not try to graph this live because despite having 64 gigs of RAM, you need a lot of memory to run what we're running this on right now. But if we start building the relationships, everyone's connected to one another. We're all actually building the same thing, which is software to run a society that is equitable, that advances technology, that lets us do things we want to do, like explore the world or surf the web. And it's actually not about the technology, it's about the community we're part of. It's about the people who are right next to us building it with us. So we have a little bit of time for questions. If anyone, I know I'm jumping all over the place. There's a lot to talk about this project. So please guide me a little bit.
Hi. Sorry, I got a little bit late to the talk, so I hope you didn't say this already, but you're using Neo4j, right?
Yes, this is not Neo4j, but we are using Neo4j.
Okay.
This is React rendering of Neo4j instance.
Okay. So I mean, I asked because I assume at some point the database will be built, and then probably someone will have access to just write their own queries in Neo4j. I don't remember the name of the language, the query language, but I remember there's a query language for that.
Yeah, Cypher.
So that's Cypher. Yeah, exactly. That's the objective, right? If I understood correctly. To at some point let people write their own queries?
Yeah, so there's a lot with regards to how we want this to evolve over time. One of the early steps will be people can write their own query. Longer term, we would love for just an LLM interface to be able to traverse the graph, and you can ask it a natural language question. Hey, I'm a funder. I find biomed projects incredibly impactful. I depend on these other projects. What should I support? What are some projects that haven't been funded in the past 2 months, that haven't had a pull request in the past 2 years, that I depend on? Where should I put my money? And then the response just tells you what to do.
Sounds really exciting. And I wish you a lot of success because the ideas that you have in mind, like the simple idea that you had, like
Right.
how is your industry being impacted by which software, and then just putting money into that back into the software. Sounds awesome. Yeah.
Doesn't it? Come help.
Yeah.
We're
Show me the links. I'll
yeah.
definitely take a look.
QR code.
Okay. Perfect. Thank
So
you.
that will take you to a bunch of links. We're building this at a program called the Open Source Science Initiative out of Focus. It's a working group of over 100 people. There's 40 plus organizations that contribute to the conversation. We're just getting things up on GitHub to open contributions up. And we're now up to maybe 6 or 7 contributors that get together once a week to actually build the stuff and once a month to discuss it. So you'd be very welcome.
Thank you. And I assume you got those 2 guys who work across the hall to work together now?
Yes.
Perfect.
Any other thoughts? We got a couple seconds. All right. Well, hope to see you in the Slack or in one of the calls. Thank you.